Okay. Bianca says, I recorded. No, yes. Somebody press the button. Maybe Joyce or another, but Joyce. Okay, super. Thank you. It's recording. I try to explain one easy way to determine see this is the solution for this quadratic irreducible. It's irreducible. Remember when the zero, when the answer for the zero say is complex or imaginary. So one fantastic way is computer discriminant. I don't know if you remember this. In Color algebra, b squared minus 46 is less than 1, less than 0. Sorry, it's a negative, it's obvious it's complex. Okay, but this is not important now. The important is that you separate into pieces. This is not repeated. But one guy, a linear, this is linear. But this is not linear, it's quadratic, no? And quadratic irreducible because the factorization is impossible, at least in the real field. And you put something like that. A, here, this is the difference. Yes, quadratic, you put the linear in the top. Bx plus c. Wow. And you need to find A, B, and C to do the partial fraction decomposition. Okay, number 4, it's obvious it's the same idea but repeated. So when the cube here, when the cube has repeated irreducible quadratic factor. And remember that the word repeated or non-repeated depends on the multiplicity. Non-repeated multiplicity 1, repeated multiplicity 2, 3, 4. And one elementary example is, well, this example we are doing today. Okay, today we solving this problem. Okay, esto es theoretical, no? Well, this is the numerator. What the important for the classification is the denominator. Okay, you know the x squared plus 4 equal to 0. The answer is imaginary, right? When it pluses the factorization and the imaginary field is x to I, similar to the last question in the test and the first test. In this case, no, we never using this for math, so we consider it como irreducible, quadratic factor. But the multiplicity is 2. As the multiplicity is 2, you copy x squared plus 4 squared, and you copy x plus 4 to the first power. So no, when the opponent 1 is invisible, but you have irreducible both in the denominator. You have, for example, cx plus d, ax plus b. Anyway, you copy one student called A, B, C, it doesn't matter. The chain, the final answer of the problem doesn't change what you call the coefficients. You call Maria coefficients, Jose coefficients, A coefficients, B coefficients. But see, I call different to you, but when you solve it, you get the same answer, right? And you put it in the correct place. So for case, be aware that you face today 4 different cases. The most common case is the easy case, fortunately. It's when you have the non-repeated. Let me illustrate the big picture of the 4 cases. Case 1, non-repeated linear. Case 2, repeated linear also. Case 3 is when it's non-repeated but irreducible quadratic. And case 4 is most complicated when it's irreducible quadratic factor. Okay, super. I can erase the board or not yet? I want to start for the first example. The first example. Okay, first example. Okay, the first example. Look, I want to copy big. First example. First example is, suppose it give me the problem way. X over x squared minus 5x plus 6. And the question say, do the partial fraction decomposition. It's like you break it down, this complicated fraction and 2 or 3 or 4, depending on the problem, different elementary factor gets easier to use in calculus. Okay? So the first thing you should do is investigate the factor of the polynomial, the denominator. It's super easy because it's quadratic. The factorization is obviously 3 and 2, no? So 3 times 2 is 6, and 3 plus 2 is 5, negative of. Everyone is agree? And you realize, wow, it's non-repeated linear. So we have one factor, okay, I copy x minus 3, it doesn't matter the order. Another factor is x minus 2, I call A and B. I call A and B, okay? And my goal is find A and B. I need to do something to find A and B. But always the same, it's super easy. First of all, you find the least common denominator. And the least common denominator is obvious is x minus 3 and x minus 2, okay? And you multiply the entire equation by the least common denominator. When you multiply the entire equation by the least common denominator, for example, from this, you multiply x minus 3, x minus 2, x minus 3, x minus 2, 2, x minus 3, x minus 2. So okay, here cancel everything. And stay alive, only x. And the second, after the equal sign, x minus 3 cancel, I stay A, capital A, x minus 2. Plus, cancel out x minus 2, I stay B, x minus 2. This is classical. In algebra, when you have equation or expression that contain fraction, the most of people don't like fraction. But one fantastic way to create one equivalent equation is multiply the entire equation by the least common denominator and magically happen, get the fraction disappear. Okay, different way to face that problem. My recommendation is using the smart value. The smart value, okay, unfortunately, we have not always a smart value. In all more complicated problem, we have no smart value. Or in other more complicated problem, we have only one smart value. In this case, no. In this case, we have two smart values. Suppose a smart value is one value of the x. And when you plug it in the equation, at least one guy disappears. It's obvious because you plug in 3 here. 3 minus 3 is 0, and the b part is gone. So you replace x for 3, you say 3 is equal a 3 minus 2 plus b 3 minus 3. And 3 minus 3 is 0. As he is 0, that part disappears. That was my intention using a smart value. Now 3 minus 2 is 1. Therefore, a is 3. Okay? Another smart value is x equal to. When you plug it into here, in the original equation, we have 2 equal a 2 minus 2 is 0 plus b 2 minus 3. 2 minus 3 is 0, that part is gone, 0, 0. Get the other way. So it's 2 is equal b, and 2 minus 3 is negative 1. Therefore, b is negative. Okay? Now, I come back at the beginning. I can see the partial fraction decomposition of this expression. For working in calculus 2 is 3 over x minus 3. Look, because a is 3. Look, I replace here 3. And here replace negative 2, no? So it's, you can write like that. Oh, in my opinion, you can write like that. 3 over x minus 3 minus 2 over x minus 2, que es equivalent, no? So when you have fraction, you have minus in the numerator, you put a minus in the front, or you put a minus in the bottom, and the 3 place is equivalent. It's the same thing. And this is the elegant final answer. And we are ready to start now calculus. Any question? Any question? Question?
No, sir. Not at the moment.
Come on. What do you want? Can I make it soon? You are copying your notebook, no? Or not? Okay, super. Everyone copy? Everyone understand? The most important is no copy. Copy is just time. Okay, good. Very good. Okay, guys, you using the chat to communicate with me or activate the microphone a little bit time or create the sign like that, no? Thumb up. I understand everything is okay. Jonak, everything is okay or no? Jonak, are you there? Jonak, can you annoy me? Okay, you annoy me with the microphone open. Okay, so definitely, Jonak, you are my old student. Can you take with me college or no? Or is the same first name and last name? Jonak Moreno. No? There are no coincidences. A ver, let me see. Yes, sir. Okay. Okay. I understand very well. Okay. Let's see another example. Another example. Of course, I complicate it a little bit, huh? Thank you, Yona. Okay. Let me see. Okay. Example number 2 is when you have repeated linear. Is the second case. One example of the second case. Okay, look. Suppose x squared over x minus 1 squared times x plus 1. In this case, somebody, not me, doing the factorization of the polynomial in the bottom. Nice, I appreciate so much. This help. Otherwise, you need to apply scientific division, factorization. I don't know. Okay, entonces I set up the format for the partial fraction decomposition. I see, oh, repetition, 2 here. Entonces x minus 1 squared. And the coefficient here I call A. This is x minus 1. You decreasing the exponent 2 minus 1 is 1. You put a 1 here, but I don't like this 1. I prefer without 1 and without parentheses. It's the same, right? B. And the other factor, que is x plus 1, que is totally non-repeated, is C. Okay? Again, the idea for the least common denominator. This is the least common denominator. Least common denominator. Are you aware? You understand very well least common denominator or no? Least common denominator is like a least common multiple, no? You take every factor. Every factor, well, no, always. But when they are repetition, you take the majority of them, no? In this case, the majority is x minus 1 squared. And you multiply the entire equation by this. Let me use another color. You multiply x minus 1 squared, x plus 1. 1 by 1, guys. X minus 1 squared, x plus 1. X minus 1 squared, x plus 1. X minus 1 squared, x plus 1. So I can see, wow, look at that. In this case, everything is cancelled. And stay alive, only x squared. In this case, cancel x minus 1 squared, 2, and stay a times x plus 1, only 1. Plus b. Well, in this case, cancel out only 1. Stay 2, x minus 1 and x plus 1. Plus c, let me see, cancel out x plus 1, stay x minus 1 squared. Entonces I can express it. This equation is complicated using fraction. 1 easier. It do not contain fraction. No? And one more time, we're using the smart value. Well, the smart value, in this case, es obvio que es, let me see, smart value is x equal 1. No? 1 is smart because when I plug here 1 minus 1 is 0, and here 1 minus 1 is 0. Stay only the term can contain a, and that's it. So 1 is 1 squared is equal a paréntesis 1 plus 1 plus b 1 minus 1 1 plus 1 c 1 minus 1. It's obvious that this guy and this guy say goodbye in the equation, no? And stay only that part, okay? 1 squared is 1 and 1 plus 1 is 2. Therefore, a is 1/2. And we found the first value. This is 1/2. Let me write here. After I want to write in elegant way, the final answer. Okay, not bad. Let's continue with the smart value. Another smart value that I can see is -1. Because when you plug in -1 here, -1 plus 1 is 0, and -1 here plus 1 is 0. Nice. I using this idea. Another smart value is -1. The -1 squared is equal a -1 plus 1 plus b, -1 minus 1 is -2, and -1 plus 1 is 0, plus c, -1 minus 1 squared. Okay, one more time happen. Okay, this is 0, and this is 0, no? This is 0. As 0 times something is 0. Okay, so we have a -1 squared is 1 positive. And -1 and -1 together is -2. And -2 squared is positive 4. It's a 4c. Therefore, c is 1 over 4. Okay, so in our partial fraction decomposition, at least I have a and b. A and c, sorry, is 1 over 4. I need to find b now. But unfortunately, we have no more smart value. Remember, smart value is the value when you plug it in the equation, at least one part disappears. Boom. But we have no smart, but we have another ordinary value I call frame value. Okay, we have smart, que is the value that when you plug it in, one part is canceled, but the frame, no. The frame is another value. I take nice. I like so much 0. 0 is good frame because 0 is super easy. I'm plugging in the original equation, 0. Okay, entonces 0 square es equal, pero I know que a is 1/2. Look, I replace. I know in the previous step que a is 1/2, 0 plus 1, plus b, I have no idea who is b. Is 0 minus 1, 0 plus 1, plus c, pero c is 1 over 4, 1/4, 0 minus 1 squared. Okay, this is the only unknown that we have in this equation is b. And that's it. Let me try. 0 is 0. 0 plus 1 is 1. 1 times 1/2 is just 1/2. Plus b. B times something. Let me see. This is -1. And this is +1. And -1 times +1 is -1. Actually, then, this sign is negative. Negative b. Now plus 1 over 4. 0 minus 1 is -1. And -1 squared +1. And +1 times 1/4 is +1. Okay, super. So therefore, I try to combine like term. 1/2, let me copy here, 1/2 plus 1 over 4. So because 3 over 4, no? 4 is, what is going on? 4, this is 2 plus 1 is 3, no? 3 over 4. 3 over 4. 0 is equal minus b plus 3 over 4. Therefore, b is equal, obviously, I move b to the left-hand side, maybe B is equal 3/4. Final answer, I finish. Okay, the only thing I need to is to write the final answer. B is 3/4. Okay, I come back at the beginning. Look here. I discovered that B is 3/4. 3/4. Okay, let me try to write elegant final answer. Elegant final answer. The partial fraction decomposition is. Okay, the first fraction is x minus 1 squared. I know that the coefficient here is 1/2. I put 1 here and 2 here. It's the same. More elegant. You can write like that. You can. Of course you can. Some people prefer that way. Personally, I prefer the other way. But it's okay. This is just cosmetic part. Plus, the second factor is x minus 1, 3/4. Okay. 3/4. Entonces 3 in the top, 4 in the bottom. Plus, the last part is x plus 1. 1 times 4. And this is the one good way to express the final. Any question? No? Super clear?
Clear.
Let me make it zoom. Can you see the big picture for that problem? That problem is really, really long. Really, really long. I remember, no. I teach in Calculus 2 in the summer, every summer. Okay, we have one problem. The student spent 1 week to do that, of the partial fraction decomposition. 1 week, guy, working every day. Because it's heavy, super heavy algebra. But I have good news for you. Good news for you. Well, no, after that. Let's continue with example number 3 I bring for you. You copy?
Our good news is it's going to take us 3 days, right?
Say again?
It's only going to take 3 days.
No.
Scary.
In the review package for this test, we have one problem. Okay? Explain 3 videos to explain. But no. Don't worry, guys. In the test, I put a straightforward example. No super big deal. You have to take advantage, because I promise this test is easy, easier than the first. It's the easiest test. But 3 and 4, no, it's very, very hard. Okay? Okay. Let me explain one example of the third case. The third case, remember, is non-repeated, pero quadratic irreducible. The example I tried to put at the beginning was 3 minus 5 over, because we have x minus 1, and we have x squared plus x plus 1. The first one is linear, super, and not repeated is the only, and the second is quadratic irreducible, because I know that the solution for this quadratic part is complex solution. Okay? The partial fraction decomposition format is something like that. X minus 1 here, a x squared plus x plus 1, bx plus c. It's a format. So the first thing is identification, the format. Okay? After, you apply your common sense. In this case, the least common denominator is obvious, que es x minus 1, x squared plus x plus 1, x minus 1, x squared plus x plus 1, x minus 1, x squared plus x plus 1. Those are the factors gets canceled, and everything is canceled in the first. Stay only, bring down 3x minus 5. Equal. A, stay. This and this say goodbye, and stay a times x squared plus x plus 1. Plus, let me see, this quadratic irreducible is cancelled, and stay only bx plus c multiplication by x minus 1. Okay? Okay, guys, this is straightforward. This is super easy. Yes, you have equations that contain fraction. You multiply the entire equation by the least common denominator. You know that happy. Everything is canceled. Stay alive only the no numerators, disappear the fractions. So we have a new equation that, by the way, is equivalent to the original without fraction. Equivalent between quotation mark, because you need to consider restriction, but no, don't care about restriction. Okay, so let me try to find a smart value. What do you think about a smart value? You see one smart value or no? No smart value in this example? No. Yes, no, yes, no. No?
1?
1. Very well. 1 because 1 minus 1 is 0. So you plug in here, 3 times 1 minus 5 is equal 8. 1 squared plus 1 plus 1 plus b times 1 plus c and 1 minus 1. Ooh, it's 0. I like that. That part disappears and stay alive only 3 times 1 is 3 is minus 2. Here we have 1 because 1 squared is 1. 1 plus 1 plus 1 is 3 is 3. Therefore, a is equal to minus 2/3. And this is my first answer. Another smart. We have another smart? No. Yes or no? No. Why no? Because here, the only number, when you plug in here, give me 0, it's a complex. I don't want to work with the complex. It's too heavy, too hard. No. Entonces, let's use in the frame value. So one good frame value is 0. 0 is nice. I like 0. Then I substitution x equals 0 and the original equation. Look, 3 times 0 minus 5.
Professor, I have a question.
Please.
Okay, is it good to say most of our friend values are possibly going to be zeros?
Yeah. The other example, remember, we have 2 smart value. But
Correct.
in this case, we have only 1 smart value, get 1. No
Correct.
more. So now, but I need to find 3 coefficients, A, B, and C. I have A in my hand. And then I suppose that when I evaluate in 0, we have one new equation that contains 2 unknown, B and C. And you need to use another strain value. I don't know, 2, 3, -1, -2. Let's make a decision, doesn't matter. And you get 2 equations and 2 unknown, B and C, and you solve the system of equations.
Is it okay? What I mean is, perfect. Thank you.
Super. Okay, let's continue. Entonces, okay, I take advantage que I know que A is negative 2/3. Substitution because we compute in the first part. Entonces, 0 plus 0 plus 0, bueno, 0 square plus 0 plus 1 plus paréntesis B times 0 plus C, 0 minus 1. Something like that, right? And the left-hand side, we have -5. Because 3 times 0 is 0, it's just -5. Here we have 1, is negative 2/3. Plus something. Oh, look at what happened here. B times 0 is 0. So B disappears. This is good. This is a good idea because I have only C. That the equation contains no two variables like we predict, sino only one. And this is -1. Entonces, actually, the sign is negative. Negative C. Do you see? Negative C. Okay. Let me confirm again. I am doing okay. It's negative C. Yeah. It's negative C. And negative C because this B times 0 is 0. 0 plus C is C. This part is C. And this is 0 minus 1 is -1. And -1 times C is negative C. Okay. Good. Very good. Wow, too many negatives. So I suppose you convert to positive. I propose you multiplication. Let me see what is the best way. Multiplication by -3, no? Because I want to solve a two problem, no? Change the sign, negative, negative, negative. When you multiply by a negative number, become positive. And also eliminate the fraction, get 3. And when you multiply -3 times -5, 15. When you multiply this times this is 2, no? It's 2, right? Because -3, negative, negative, positive. Here is plus 3C. Subtraction, 15 minus 2, 13, equal 3C. Divided by 3 both sides, C is equal 13. Pero es positive o es negative? Es positive. Es positive. Guys, using your imagination, you don't need to do exactly like me. This is a linear equation, and you're using your imagination. Some people prefer, for example, working with the fraction here. I don't know. It's up to you. Okay. Entonces, we need, we have no more smart value. We need another frame value. In my paper, don't ask me why, I select -1. Because I want a small value. 2 is positive. 3 is positive. That's too much. Okay, entonces -1. I use a -1. Yeah, I come back at the beginning. The beginning is this equation. Look, replace x equal -1. Under the consideration que I know A y I know B. Y I know C, sorry. The only unknown es B. Ok, entonces negative, no, 3 times -1 minus 5 is equal -2/3 because I know que A is equal to -2/3. Entonces we have -1 squared. Es positive. I know. Minus 1 because -1 is just -1 plus 1. Plus parenthesis B times -1 because x is -1, so I put a negative here if you want. Plus C, que C is 13/3. And here is -1 minus 1, something like that. Everyone follow me with this computation? Anyone?
Just remind me again why you made the B negative.
Well, the reason is because, look at that. Si you suppose in your mind that here is -1.
Right.
Okay?
And negative times positive. Okay, I got it now. Thank you.
Okay. Okay, therefore, we have here -3 and -5 and -8, no? It's negative. +1 and -1 is cancelled, 0. So we have only -2/3. Good, very good. Plus something. We have, well, -1 and -1 together is -2, no? And -2 multiplication by -b is +2b, no? And -2 times 13/3 is -26/3. Make sense? Okay. We combine like term maybe. When you combine like term, for example, in this case 28, no? It's -8 is equal -28. It was -2 and -27 together over 3 plus 2b. And bueno, I propose you multiplication by 3. By 3, why not? If you want to eliminate this fraction, then we have negative 24, we have negative 28, and we have 6b. This is plus, sorry. 3 times 2 is 6. 3 times 8, negative 24, and 3 times 3, you cancel out that 3, and that 3 stay only 28. Final answer then, I move 28 to the left. We have 28 minus 24, okay, 4, equal 6b, no? But by 6 both sides, b is equal to 4 over 6, in lowest term is 2 terms. Okay? Is the final answer? Let me copy now my final answer. I copy. Look, meeting with Jorge. Okay. The final answer, remember, the expression is a over x minus 1 plus b x plus c divided by x squared plus x plus 1. Entonces, en the middle of the process, I discovered que a was negative 2 terms. I discovered that b was positive 2 terms. Look here. And c, I don't remember very well, was 13 over 3. Okay. And one elegant way to write that is 2 minus 2, 3x minus 1. You can write like that. Another way is you put the negative if you want in the front. It's the same. Plus, but this situation happens now that the same denominator contains different number. So I propose you to do more elegant. Copy the denominator 2 times. In the first one, you put 2 terms. Put 2 terms. In the second is 13 terms. Wait. Sorry, I forgot x here. Look, this x I forgot. Important because it's b. B is 2 terms. And this is super, very, very elegant expression to start calculus 2. Some people prefer fraction. Okay, no problem. Some people prefer in that way, minus 2 terms, x minus 1, plus 2 terms, x plus 13 over 3 over x squared plus x plus 1. This is another possibility, but it's not good for calculus because you need to break it down. Remember, calculus using this partial fraction decomposition to apply one operator. It's integral. You don't know this, but no, it's not important. This integral you apply here, independent, here and here. Okay? In this case, a little bit, this is easy. It's almost the same, but this is not easy. It's more complicated. In this case, separate more is easier. Do you understand this example? This example was irreducible quadratic, non-repeated. You too long, eh? I try to select the super elementary problem to explain the theoretical part. Another is crazy. I want to finish the example. I want to illustrate how we are doing this, but not in my test. In my test, no, because this is precalculus. In precalculus, you need to show the word. In calculus 2, no. Because in calculus 2, you need to show the word, but you need to show the word of the calculus part. And the algebra part behind the calculus part is for the teacher. See if you could take with me, no? I don't care. I suppose that you know. Okay, so you don't need to show me in detail that part. We use software. Okay, I want to show you when in the last part of the class. Okay. Okay, let's solving one more example. One more case. Erase the board. Yes or no?
Go ahead.
Okay, go ahead. Okay. This is one example of the case 4. In the case 4, remember, we have irreducible quadratic, but repeated. This is the most complicated case. Of course, I try to select one not too long example to illustrate very well this idea. Entonces, you separate, for example, this is irreducible quadratic, impossible factorization like that. No, impossible. Because it's I. So you do, pero it's repeated. So you take square and shoot no square. Okay, square and no square. You put AB, I don't know, either way, AX plus B, CX plus B. And you need to find A, B, and C. And D. Okay, again, we multiply the least common denominator. In this case, it's obvious is X plus 4 squared. So we have only X cubed plus X squared in the left-hand side. The right-hand side, we have CX plus D. In the last, it's cancel at least one. And we have AX plus B multiplication by X plus 4. And you know, in this case, a smart value, we have no. Do you understand why, no? Because the only guy you can plug in here in order to get 0 is imaginary. So we have no real. So I propose you doing another way que I explained at the beginning. This is X plus 4, no? I forgot this square, look. Sorry. X square, and square. This is the least common. So I propose doing another way. I don't know if you remember last time when I introduced the topic, okay, we are using system of equation for solving this. Okay, let me try. This is X cubic plus X squared, CX plus D, stay the same. And you FOIL here. This is AX squared, X cubic, sorry, because it's 1 plus 2, no? This is 4AX. This is B X squared. And this is 4B. Okay. Now I copy here. Actually, we have two polynomials. And to be equal, two polynomials. Okay, let me organize the upper. The upper polynomial is in descending order of the degree. For example, this guy is cubic. I copy first. It's the higher degree. The second one is this, no? B X squared. And the rest is to contain linear, is this and this together, no? This and this. Entonces, like C plus 4A X, no? By factorization, factorado X here. And the last one is D and 4B, no? es the term que do not contain, independent, ¿no? Que do not contain x. Okay, entonces we use the property for the equal to polynomial, ¿no? Si es equal to polynomial, es because term by term are equal. So in the left hand side, I can see that the coefficient in front x cubed is 1. Therefore, it's obvious compare this and this a1. Likewise, 1 in the square, b is 1. Super. And this guy in the left hand side are missing. Therefore, c plus 4a is 0. And d plus 4b is also 0. But I have in my hand a and b. Okay, entonces c plus 4 times 1, que es just 4, because a is 1, is equal to 0. Therefore, c is negative 4. And d plus 4 again, because b is 1, look, is equal to 0. C, d, sorry, is negative. So the answer is, I come back at the beginning. Okay, let me erase that part of the least common denominator part. Okay, so my answer is negative 4 x minus 4, because d is negative 4, and this is x plus 1, right? And the rest stay the same. Let me copy my elegant final answer. My elegant final answer is D. Final answer. Okay, look at that. The final answer is minus 4x minus 4 over x plus 4 a squared plus x plus 1 over x plus 4. Final answer. I tried to find this example. It was very, very easy. The majority of the examples look like that. It's very, very, very complicated. Very, very, very complicated. Okay, I want to. Okay, question, guys. Do you understand or no? Perfect. Feli Valde, say perfect. Thank you, Feli. Okay, look. And now the fantastic moment. The fantastic moment. Okay. In my test, you need to prove step by step. But you can check it always. Any problem using, guys, let me explain. Using Wolfram alpha. Wolfram alpha. You hear before about Wolfram alpha? Never? You hear? Or you hear? No. Okay. Okay. Wolfram alpha is similar to Desmos, but Wolfram alpha is no graphic. It is to compute, to solve an equation, to solve a system of equation. So from today, we're using Wolfram alpha to do this partial fraction decomposition. Okay. But in the most complicated cases, we are doing in the next topic is the solution for the nonlinear system of equation. We're using Wolfram alpha when it's more than 3 variables. It's super hard doing by hand. And there are no rule. It's crazy. Entonces you go to the www.wolframalpha.com. Wolfram alpha, like that. .com. And you try to find inside. I want to show you now. I want to find algebra. One topic because we have algebra, calculus, linear algebra, differential equation, crazy, everything we can solve it. But it's not perfect. This is the artificial intelligence, But artificial intelligence not always is good. Okay, because solving elementary example, you could solve 2 plus 2. So see, this give me not 2 plus 2, but another problem. Give me a correct answer, but a weird answer. I don't understand anything. However, doing by hand is much better. So you need to find the balance between the software and the by hand. No? So you go to the algebra and specifically in the bar, and you put equation or something. You put partial fraction decomposition, EFD, and you copy the expression. Close the parenthesis, and you press one button here, and give me the answer. Down. Right? Let's do it. In the previous class, we solved one elementary example. Remember, was 5x minus 1 over x squared plus x minus 12. But I want to repeat again because it's very, very important. What case you suppose que is this? Case 1, 2, 3, or 4? I have no idea, no? The first thing is factorization the polynomial in the denominator, no? Que es, I suppose que 4 and 3, no? 4 times 3 is 12, 4 minus 3 is 1, positive 4 and negative 1. Entonces the partial fraction decomposition is x plus 4. I call this guy A. X minus 3, I call this guy B, no? Okay. Multiplication, everything by the least common denominator. That part is super easy. I skip that. When you multiply, stay only 5x minus 1 in the left-hand side. In the right-hand side, we have x plus minus 3, no? Plus b times x plus 1. Everyone follow me so far? Everyone follow me so far? Was easy for you this? Okay, super, right? Because I need help. What is the smart value? Yes. Exactly. What is the smart value in that case, please? A smart value. 3. Good. 3 is good. Entonces, 5 times 3, 15. Minus 1 is equal a. Well, this part is 0, no? Equal 3 minus 3 is 0. That is the reason que es a smart value. Entonces, actually, it's b 3 plus 4. And 15 minus 4, 14. And 3 plus 4, 7. B is 2. And you go be here 2. So you erase this number, this letter, this variable, and you put 2. All right? We have another smart or no? We have another smart or no? Yes, no. No, yes. Negative 4. Very well. Negative 4 is another smart. Plug in negative 4. Entonces, 5 times negative 4 is negative 20. Minus 1 is equal a. Es minus 4. Plus 3. Es minus 3. Minus 3, minus 3. Plus negative 4. When you plug in here, negative 4 plus 4 is 0. Disappear that part. No b anymore. No b. Entonces, negative 21 equal negative 7a. Divided by negative 7 both sides. A is 3. I come back at the beginning of my problem. I erase that value. And the answer is 3. And this is my final answer of the partial fraction decomposition. And so my goal now is show you how we are doing this job using Wolfram alpha. Let me try to using Wolfram alpha. Okay. Okay. Look. Switching screen, Wolfram alpha, window. There you go. Do you see? Okay, this is the Wolfram Alpha format, computational intelligence. And you copy P, F, D, partial fraction decomposition. And you copy in this format the expression. Be careful with the parentheses. So my recommendation is PDF as a function that computed partial fraction decomposition. So you copy the rational expression. And the top, you put the expression get 5x minus 1 and between parentheses. Okay, enclose everything in the inside the polynomial in the top. Likewise, another parenthesis can involve. Okay, I forgot, not intentionally, I forgot another parenthesis. However, Wolfram Alpha is smart. I understand they make a mistake. I copy right here. Look, I copy right. This is the partial fraction. This is the confirmation. You see, wow, it's exactly the problem that we are doing. Now, this is the answer in partial fraction decomposition. So you press this button, red button. Wait a second to the pada-boom, pada-bang, and we get this answer. This is the confirmation that we are doing okay, and this is the partial fraction decomposition. And if you want to see step by step, you click here and show you step by step, but you need to buy the option you need to pay for show the step by step. But it's only $3. It's only $3 for the people who want. This is totally optional. And where I come from, Wolfram Alpha, let me show you step by step. You open, in this case, I open Google Chrome. I prefer Google Chrome. I put Wolfram Alpha. Everyone follow me? Do you see the computer? Everyone follow me?
Yes.
Okay. Wolfram Alpha,
Yes,
look.
sir.
Okay. You click here. Wolfram Alpha Computational Intelligence. Okay. You select here, look, algebra, plotting graph, calculus, geometry, elementary math, differential equation, statistic. Wow, unbelievable. No, another side, chemistry, physics. Wow, amazing. Entonces, I select algebra. You select inside the algebra any box gets equivalent. Simplification. I don't know why I like to select equation. Look, for example, this is a quadratic equation. You put solve, and you put a quadratic equation, and immediately when you press the button, give me the solution using the quadratic formula. But in this case, I put PDF, partial fraction decomposition. Look. Partial fraction decomposition. Open the parentheses. I type in my equation. Okay, I put one new parenthesis, enclose everything in the top. Finish the top, division, another parenthesis, enclose everything in the bottom. Okay, it's x power, always like a calculator, we're using this symbol to the power, square, plus x, minus 12, and close the parenthesis to indicate ending the denominator part, and last parenthesis can enclose everything inside the function get partial fraction decomposition. You press the red button, wait a second, to pam pam. And this sense. Do you see the process? Do you see
Yes,
the process? Eso, bueno. Okay. D1, can I do for you another problem? See, we have time to do another.
Yeah, that would help out, Professor.
Okay, let's do it by hand. I don't know if we have time to check in the partial fraction decomposition using Wolfram Alpha. Wolfram Alpha. Try to typing in your computer home Wolfram Alpha and manipulate this because we are using next class. Maybe next class, yes. Okay, let's go to the board. It's a board. You see the board? Board. Clear the board.
Thank you.
Okay. Okay. One more. The last one. I promise. X squared plus 2x plus 3 over x plus 1 x squared plus 2x plus 4. Well, what should I do? What should I do? First of all, I need to identification. Is case 1, is case 2, is case 3, or case 4? I recall, case 1 is linear, non-repeated. Case 2 is linear, repeated. Case 3 is irreducible quadratic, non-repeated. Reducible quadratic, repeated. I can see here one linear factor, que es x plus 1 es obvio que es linear. So I'm not clear what's going on in this guy. Is irreducible quadratic or you can factorization? We can or we cannot? What do you think? I tried to find two numbers and multiply, give me 4. Okay, we have only two possibilities, 4 and 1, or 2 times 2, no? And when you're adding a 5, when you're subtracting a 3, when you're adding a 4, when you're subtracting a 0, we have no number, right? Another more elegant way to prove that this is irreducible quadratic is using discriminant. B squared minus 4ac. B is 2, A is 1, C is 4. Plugging in is 2 squared minus 4 times 1 times 4. This is 4 minus 16. Oh, it's negative. The negative 12 is complex. That means exactly we predict here by intuition that this is irreducible quadratic. We cannot factorize it. Okay, I understand. Now I separate this in partial fraction decomposition in two pieces. I copy x plus 1, que es de linear. I put A. I copy the irreducible quadratic. Entonces, in the top, what I write in the top? B or bx plus c. Bx plus c, right? Do you understand what? Or no? You understand or no?
It's already giving you the 3. It's already giving you C. So you're just going to take C instead of trying to find C. You already have it. Is that correct?
No. The problem is if the denominator is irreducible quadratic, if the denominator is irreducible quadratic, therefore the numerator, the format for the numerator is bx plus c. Okay, if the denominator is linear, it's A. Si the denominator is irreducible quadratic, like this example or another example, we cannot a complex. The format is ax plus b. Okay. Do you understand the idea?
Yeah.
Okay, good. Now the rest is pretty easy. The rest is multiplication. Everything by the least common denominator. The least common denominator is x plus 1 times x squared plus 2x plus 4. So we have in the left hand side, we have x squared plus 2x plus 3. In the right hand side, we have 8 times x squared plus 2x plus 4 plus bx plus c times x plus 1. Okay? And we have a smart value or no? We have a smart value or no? No?
-1.
-1. So we always have a smart value when you have a linear factor. -1. There's -1 squared. -1 squared plus 2 times -1 plus 3 is equal 8 times -1 squared, que es por 1, minus 2, because 2 times -1 is -2 plus 1. And that part is gone, no? Because -1 plus 1 is 0. Okay, okay, I like that. Entonces it's 1 minus 2 plus 3. This is 2, no? Because 1 plus 3 is 4, minus 2 is 2. Equal. Here we have 1 plus 4 is 5, minus 2 is 3. It's 3. 3. Therefore, A is equal to 3. We have another smart value or no? Another smart value?
0?
This is not smart. This is, well, yeah, I got frame. It's a colloquial. It's a
friend value.
It's a mnemonic that I create. This is my language to explain to the student that they are super value and they are another good. Those are good and smart or frame or whatever you want. It's 0. 0 is good. 0 is good or frame. It doesn't matter what you want to call it. 0. When
Could another smart value
say again?
could another smart value be -2? Because -2 squared, I mean, it is 2, but no, oh, it won't make it 0. Never mind, never mind.
No. They are no real value. Okay, when you plug it in here, give me 0. No.
Oh, damn. Okay.
I recall. Remember, I discovered here when I tried to find this complex solution. The only guy that you plug in here is complex number. Real number do not exist.
Okay.
The only smart is -1. Okay, eliminate that part. Okay. 0. Let's try 0. 0 is easy because 0 squared is 0. 2 times 0 is 0 is just 3. And the left hand side we have 3. Pero I take advantage que I know que A es 2/3. Paréntesis. Entonces 0, 0 es 4. Just 4, right? It's 4. Plus something. Let me see what happened in that part. 0 disappeared that part. Boom, boom. This is C. 0 is so C. Wow, it's C, right? It's C. And this is 8 over 3 plus C. Therefore, C is equal to 3 minus A over 3, no? Es LCD es 3, es 9, minus a 1/3. C is 1/3. C is 1/3. Okay, I have in my hand A and C. I don't know what happened again. The last value is B always. So another frame or good value, frame is equal good in our language. Is X equal 1. Or what do you want? 100. 100 is too big, no? 1, 2, 3, 1 is perfect. So when you evaluate 1, this is 1, this is 2, this is 3. This is 1, this is 2, this is 3. It's 6, no? It's 6. In the left hand side. In the right hand side, we have, let me see. We have 2/3. 2/3. Wow, guys, the time is over, no? I want to do quickly. 1 plus 2 plus 4 plus B plus 1/3 times 2. And you solve for B, and the answer is B equal 1/3. Okay. Too much. Joyce, I want to take a picture. I send the answer for the test. Who more need the answer for another student can need? Well, you email me. So if you need the answer, you just email me. Yeah, I send to you. Okay? Bye. Nice.
Okay, Professor. Thank you. Have a great day, sir.
Sure. You too.
Bye, Professor. Thank you.
Mm-hmm.